Well, hello everybody, and welcome to the last talk on the How to Multiplayer Dev Summit. Today, we will be tackling an age-old question, adding multiplayer. What does that mean in reality, and what are the ramifications of deciding to go down this path? My name is Timothee Engel. I'm a technical production specialist and multiplayer consultant, and also the founder of How to Multiplayer. So, this topic, why and why now? Well, it is a question that just comes up way too often. And as especially somebody who consults and who knows other consultants and co-developers and service providers, it's one that's kind of annoying because the answer is, as you'll see, rather simple, even though the implications are not. Before we dive into the details, though, let me give you a quick overview of what we will be covering. So, the actual topics we will cover today are first, the theories involved, specifically the history, the fundamentals, and the differences. And then we will move on to the things in practice, namely the assumptions that we will be using then in the case studies following this. So, number one, is this a technical talk? No, it isn't. So if you're looking for a guide on how to implement or add multiplayer to your game, this ain't it. What we'll be focusing on today is technical production, tech design, operations, and business, because those are the areas that you will have to actually be in agreement on for this challenge. What about MMOs? Same thing, not the talk you're looking for. MMOs don't use the same type of tech as pretty much any other type of multiplayer game, just because of the scale and the synchronicity of the worlds they share, usually across continents. So, with that out of the way, let me give you just a quick version of this whole talk, and then you can decide whether you want to hear how we got to this conclusion. The short version is, don't do it. All right? Cool. Seems like we're all in agreement on that. Now, let me give you the quick and long version. Please, for everything that's holy to you, don't do it. Well, that's the long version of what I would like to tell most people. But the long version is this. Can you do it? Of course you can. Everything's possible if you have the will and the resources. The question is that really the best way to deploy it for your studio and, of course, for the players? Now, the real question is, should you do it? And the answer is almost always no. But, again, there are considerations. The considerations that we will dive in right in this talk. In practice, we need to differentiate between two things. There's social play, that is easy. Then there's interactive play, that's medium to extremely hard, nearly impossible at times, depending on what you're after. The takeaway that you will have for this talk is to add or not to add multiplayer, and specifically to make the argument either way of this conversation, because, as I said, it is possible. The real question that is always on everybody's mind is it worth the investment, the time, and the nerves that it requires? So, first things first. What is the actual ideal scenario if you're even thinking of possibly, eventually, considering doing multiplayer? Well, first, you need to start with multiplayer requirements. Now, this is simply due to the fact that just like if you do a multi-platform release, you look at what are the biggest constraints for the realization and the development of your concept. And multiplayer technologies have more constraints in terms of how pipelines need to be set up and workflows than single-player experiences. But you can start with those requirements and then still build the single-player experience. You just have to know what the limits and the constraints of your initial requirements are. That is the key order that matters. Now, multiplayer is often, well, simplified and, in my opinion, used too narrowly to describe what it is. So let's dive into the two forms that I already mentioned before, namely social and interactive. Social play is something that you'll see in, honestly, most games that have any sort of live component these days, namely leaderboards, clans, groups, chat, ghost races, for instance, the ones like we have in Mario Kart, and of course, social media sharing, although that seems to be going the way of the dodo, despite PlayStation's best efforts, or Twitter's best efforts to kill everybody's features on that front. Now, this relatively simple in terms of concepts, as you see, because those are all things that connect players. But connecting doesn't mean interacting. Interactive play is basically actions that have an impact on the environment or on other players or on the outcomes of the current situation. In other words, those are features where an interaction will shape the actual gameplay that is currently taking place. And so with these two considerations in mind, it's really important to do one thing, and that is reframe the perspective of how we think about multiplayer and single player. The common wisdom is that single player is a game for one player, and that multiplayer is just one game for many players. And that is literally what these words mean. But there is an inherent problem with this because we're then focusing on the game rather than on the experience itself. If we turn this around and focus on the player, we can say that a game session, meaning a game experience, is played by one player, therefore it is single player. And if we have that same game session accommodating multiple people to experience it at the same time, then it is multiplayer. And it's this definition that we'll be using to go through the next steps, and that is really the guiding principle with which you can think about multiplayer while still designing for single player, but assuming the right constraints. Right. So theory. Important and informative. And the first question, of course, that we always get is, why is this a thing? And there's many reasons, but they can be broken down into three categories: history, priorities, and misunderstanding. And let's start with that very first one. What is the first misunderstanding we get?
First-person shooter, set the graphic style to AAA, then finally just click the Make Multiplayer button. Now you have your PC game, and to make the console version, just go to the files and rename this .exe to .ps5.
Now, I mean, I know, right? That is how simple it is. Or at least how simple, everybody that's not developing games tells us it should be, whether it's players, people with money, or, anybody that has an opinion on the subject. Now, of course, big whoop, it's not the case. Now, the actual reason it's that it's an anachronism, meaning it's something from a past time or from a different time than the one that we currently live in. So, and for that, it's important to understand the actual origin of adding multiplayer to a project. In the early 2000s, when multiplayer began to really be a boon right around the time we had Counter-Strike 1.6, Halo 2, and the Call of Duties of this world, well, what actually happened is that studios were building a game and then a publisher would commission a multiplayer mode that would be built usually by a separate studio, often in a different engine, commonly Unreal 2 or 3. What would then happen is that these two things would be built separately. The multiplayer mode would try to tweak the design settings to match the experience in the single player, and both would simply be packaged on the disk and be accessible through a menu. So as far as the end user is concerned, it is the same game. But from a purely development perspective, it is actually two separate ones. Now, this was possible because at the time it was literally just a multiplayer mode, a small arena, usually of some sorts. The best examples is usually the early Splinter Cell games that had some sort of like spy versus enemy mode where one would crawl in the arena and the other one would have to detect it. It's also where we usually notice that it's a bit disjointed, like the multiplayer experience and the single player experience don't really share a world or concept. But yeah, hey, you have multiplayer, which is what was important. Now, of course, the actual thing is nowadays it's this. Multiplayer is a core part of the single player experience. It is part of it, it's one project, one code base, one game. And that's the issue, sort of speaking. But it's also the opportunity. Because as you remember, if we look at it from a game session perspective, the way we could look at it is this. All games are single player, but not all games are multiplayer games. And using that, we can really think about how we want to define it. Building with multiplayer from the beginning means we can have it. Adding it afterwards makes it difficult because the initial product is not compatible with the target that we have. And the priorities that really impact us here are usually, hey, first we're going to prototype, then we will make the vertical slice because we have to pitch for funding. And of course, while we fund, we still want to go into pre-production because we can't waste time and wait for money. Then we hit pre-production, and eventually, if we still have time and money left, we'll add multiplayer. But as any technical person here will know, hey, there's nothing more permanent than a temporary fix. And that also means, in our cases, once there's a creative direction, that's what we stick into because we already have the foundation. Why would we change it? It would cost pain, time, and money. And who has that? And so the real misunderstanding is where does multiplayer come in and what is the resulting impact on cost, price, the repercussions for the teams and the pipelines, and most importantly, for the reason for this game to exist in the first place. And these misunderstandings, of course, then lead to other things. Here again, often led by things that are not developer-focused and as, hey, well, you already have local multiplayer, so that must just be feasible online, right? Or worse yet, well, as previously mentioned, we'll just add multiplayer after we have found the time, which, as we already know, we have so much spare time left in our development timelines, like we can definitely find some extra one to develop a new feature. And then finally, it's also the definitions. Because multiplayer, in pretty much every conversation we have in this industry, or at least the ones that are largely publicized, we have real-time games and PvP and esports games. Those are among the most challenging, not only to build, design for, but also operate and monetize. What we also have, however, is asynchronous games, turn-based games, co-op games, PvE games, and social play. All of these are much, much more realistic, simpler to build, and less costly to operate in the long run. They still share one key aspect, and that is the social component that players seek when they play together. Now, the important thing, like with every decision, is know the stakes, know the stakeholders. And so we always need multiplayer, but who says we do? And depending on who says it, there's a difference in impacts. Differences that may appear to be the same if we look at it from a single player perspective, but have, as I mentioned, an impact on how we do contribute to the game, how we do build it, and how we do operate it. And the very first one, and anybody who has already come to any of my talks knows it, that is latency. Latency is an absolute killer. Latency is unavoidable. It's a physical phenomenon that we have to contend with. The best we can hope for is the speed of light, but even the speed of light is not immediate. And that is because data is digital. Well, is it? No. The data is digital, but what we use to transfer is analog. It's physical, so we are constrained. And with that in mind, we have just to think Okay, latency is just part of the game, which means, contrary to single-player games, we cannot have atomic actions. We cannot have something get triggered and immediately pop up on the UI, or immediately trigger a sound, or immediately update a stat. We always validate and synchronize this information. So latency has to be accounted for in every system, in every design decision, in every feedback system, in every animation, VFX, SFX, the whole 9 yards. Now, mention again the difference in requirements. If you do a real-time game, that is much, much more sensitive to the previous point of latency than if it's asynchronous or turn-based. The same way as an asynchronous game is much simpler because it can use a database and it doesn't have to communicate in real time or even at the latency that a turn-based game would. The next one, and that is probably the most critical, that is so often overlooked. We just had 2 fantastic talks on monetization, and that is the business aspect. The way you price your game, the way you will market it, and the way you will do user acquisition, and more importantly, user retention, is entirely different. So that doesn't touch you, but does your business team have the right tools and the right mindset, and often enough people to change that model? Then there's the community, and that's a whole different can of worms. That's, well, can be very pleasant when the shit hits the fan, as we all know, and players are very graceful when we make mistakes. So this is something that has an impact most than anything. Yes, financially, because you might need an extra person, but also on just the morale and the mental health of the team. So do consider the impact here. Operations, of course, because now you have content pipelines you didn't need before, and you need live operations as well to roll them out continuously everywhere and usually across the world. Which also means, what do you do about sunsetting? Can you just leave the project, go its merry way like you do or not? A topic particularly important at the moment, given that we are seeing the do not kill the game initiatives that aim to keep games alive after developers or studios or publishers usually decide to no longer operate them. All of these have implications. And these implications have to be understood from the beginning, and now we're going to dive at how exactly these affect you in the development process itself. And the first one is that the networking tech is a first level dependency. It's not something that, if you're using, let's say, Havoc or PhysX for your physics system, you may be able to just swap out the APIs and get some benefits, but networking can't, because the most simple version, the thing that transports your information from A to B, the so-called transport layer, has to be tied into your engine. You have to tell it how and what to send. This is an arduous process because you have to define everything from the ground up. And usually, you don't do that yourself, but rather you will use an SDK that already implements that. If you're in the Unity space, that can be Photon, it could be Mirror, it could be Unity's new transports, netcode for game objects. If you're on Unreal, you might use the in-house solution or SnapNet. There's any number of things. But even if you do, all these solutions have opinions on how things should be done, and therefore you will have to follow that procedure. Now, fortunately, there's only 2 things: state transfer and determinism, so at least on that front, that's easy. We will not speak much about determinism today because that can't be added, but we'll stay on state transfer. And here also, just a reminder, there is only these 2 types of technologies. Every fancy name that we've had over the last couple of decades always falls into these things, because you either have to synchronize the state or the input. There's nothing else in the game that you can't synchronize to begin with, so you have to fall back on these 2 fundamentals. But then there's the infrastructure. The infrastructure is your walled garden that protects the whole game and allows it to operate. Again, especially what happens to sunsetting. This is something you have to have. There will be a debate about in-house solutions. Usually, this means what are the licensing fees? Can we contend with our technical team that may not want to take something external and would want to build it themselves? And of course, what is the impact on production? Here again, time and people. The very simple answer is, if you have a specific issue that you have constantly and repeatedly, then build it yourself because you know what to do. For instance, if you take Paradox, they only build 4X games, therefore they build a 4X game engine and they use that for all their games. Makes sense. However, if you have a generic problem that is singular and you don't have the expertise, then you should buy it in. Otherwise, you will have the impact that many of EA studios have felt when they try to cram Frostbite into every possible game. Operations, there's one thing that's very important, and that's probably the only part that is plug and play, sort of. And the problem with that is that we all hear the marketing aspects of, hey, just use this, it's going to make your game multiplayer. Just use that service, you can swap it out later if you need to. And this is not entirely wrong, but it's not entirely true either. It's a somewhat biased reality. And the first reason that is because we have to consider, okay, what's the authority level that we need? Now, as I mentioned, in state transfer, we have plenty of choice. In determinism, we don't, because the fundamentals are different. And even if we just look at what it means for us and servers, there's so many. There's relay servers, there's game session servers, there's orchestrations, databases, user counts, content distribution networks, and so many more. So even if you just look at what's plug and play, like which one do you want to plug in and plug out? It's so many variables that you have already to tie together to build your infrastructure that you have to consider which aspects do you want to add, at what point, and what are the failure and safety systems. Now, of course, again, there's so many more to that, but even then, you have to think about backends. Are we talking user counts, authentications with the platform holders, economy, payments, the balancing of your actual design and how you distribute new updates and content? The idea is almost countless here again. So it is easy to say something's plug and play if you look at one aspect. It becomes a whole lot harder to argue that if you look at all the things you need to plug and unplug to achieve that particular outcome. Especially since backends communicate with the infrastructure only at best, so it is definitely the part that you can swap out or swap in the easiest, but sometimes you need a backend within that infrastructure to coordinate the infrastructure and the other backend. So you kind of get a stacked problem, which, I mean, is at best inconvenient. But the real ramifications of how this really affects everything, and really the aspect that we need to remember, is that it affects the target experience. First off, not everything has a technical solution. Anybody who tells you that probably hasn't seen enough of the solutions and the problems that you're facing. And the tech is only one part of the solution in general. Design is important, as is every other discipline, to achieve it. In particular, coming back to my very first point, because of latency. And the way it affects design is probably the most important one, because it affects the world and level design, the combat design, the interaction design, the feedback design, your camera, your control, your character, pretty much everything that the player will immediately interact with. And then the feedback design, the way you present your UI, the way you design your SFX, VFX, your music, it is all absolutely tied together. Because we can't rely on immediacy, we have to deal with latency. It can't be atomic, it has to tie into the prediction and rollback algorithms of your engine, which will impact then the ultimate way how it is being presented visually to the players. The best example is usually headshots, because they have really 6 stages, even though we feel there's only one. I click, bam, they die, I know. No, we press a button, then you have a system that will do VFX and animations locally just for that shot. Then the server may or may not confirm the hint, and SFX will play to validate or cancel that initial confirmation. Then you will have some extra VFX, usually also ragdoll, and then only will the UI increase, and usually that is also tied to another layer of SFX to validate and attract the attention there. So this is a lot of smoke and mirrors, essentially, for something that we are thinking of immediate. And then there's animation, probably the thing that we all know can afford the most shortcuts in single-player development if you tie everything to your root motion, to your animation frames, and other triggers. And that is really, really painful in multiplayer, because you need to make a distinction between gameplay and feedback. Now, if you have a 2D game, for instance, or even just a 3D game where your character walks around, the fact that there is movement is ultimately not related to gameplay, but more that the fact that there is a change in position, and therefore we're giving feedback on the fact that there has been a change. But if we take games like, for instance, fighting games, which have hitboxes, hurtboxes, and the actual gameplay visually represented, and it is tied, visual representation is tied to the result of the game states, then that cannot be taken apart. And so knowing the difference between the two will make your life a lot easier to know already how much data you have to synchronize and whether or not it is even realistic to do so. The impact on tooling and assets is probably the one that is the most underestimated. The pipelines, the workflows, and the compatibility of all your tools, all your pipelines has to be reevaluated, because it doesn't mean that they will work online. Almost every tool that you will purchase of an asset store, or usually even providers, are primarily made as black boxes for single-player games, meaning that if you try to then use it to synchronize data or read data out, it might not be feasible. Assets, it's a lot easier, because that's data that doesn't need to change and therefore doesn't need to synchronize beyond maybe an ID for identification and loading purposes. And then you have the pipelines and workflows for your dev operations, continuous operations, version control, iterations, and probably the most important one, QA. The simple fact that you need to run 50 or more clients to test your game means you may DDoS yourself if you run that locally. And it sounds like a funny anecdote, but there are several examples of studios getting cut off by the internet provider for a day or two because they tried to run 200, 400 clients locally, and the service provider identified that as an attack on its services, because usually you don't have that many connections from a same IP. So there's infrastructure to consider and processes as well. But so, in summary, what can we actually add in? Well, client authority can be added in because that's all local. You just let the players decide, like you already do in single player, and just communicate what their decision was and the result to everybody else. That's usually something you'll see in co-op or PvE games. Backend services can be added with a big asterisk, depending on what it is you need them to do, and also what you already have in that depends on them. Same goes for live operation systems. What you cannot add is PvP or esport grade things, because then you would have to essentially rebuild and take apart the fundamental game structure that you have to respect the authority model that you have to find in those type of architectures. Again, entirely feasible, but that's certainly not something you can just add into, but that is really a rework of the whole thing. But with that behind us, let's look a bit at, in practice, what can we add, how can we add it, and what we can add at all if we can. The working assumptions are the following. Number one, we're only looking at state transfer, not determinism, because as I mentioned before, determinism requires an entire infrastructure and an entire type of system that is interdependent and cannot just be plugged in. Then we will also look at the three mindsets, that is adding, hacking, and porting, with the exception that adding goes out of the way, because you have to just be aware that if you have a project, and that goes as well for single players in general, if you try to tack on features, you're not adding, you're just hacking them in to begin with. So best case scenario, you're hacking multiplayer into your game. More realistically, depending on the scope of the change and the importance of it for your game, it will be a porting effort. So you'll have to look at new technologies and just assume that the single player is the first draft of how the system should work but you will have to rework it, rework the design, and most of the environment to make the experience what it's intended to be in this new context. Resources that we'll be looking at is the impact on financial, operational, and time. So how much more does it cost of any of those to achieve the target? What we'll be looking at for the actual games themselves is three things: design, gameplay, and infrastructure. Essentially, the aspects that are required to provide the game experience. Then there's, of course, business and production, which, as you may notice, is the very same thing as the one before, because it is the same metrics that they have to utilize to meet their own goals. And that allows us to talk about the case studies now. Number one, and that is the easiest one, it's social play. Social play is a term that surprisingly isn't used as much as you'd think. It was popularized by EA, of all things, and specifically for Mirror's Edge Catalyst. Now, the reason that was so heavily emphasized is because everybody thought, hey, Mirror's Edge would be a cool parkour racing game. Why don't we have multiplayer? There's mods out there to have that. There is a lot of demand from the player base, and there were mumblings in some releases, in some marketing talks that yes, this might have multiplayer. But the reality is they ultimately had social play because they had just leaderboards. They had a couple of things that you could pick up in the environment to leave notes similar to what you have in some Dark Souls games. And more importantly, they emphasized that because, well, they didn't want the player outrage once the game released. Understandably so. And so the features that we are looking at here in terms of social play is essentially leaderboards, friend lists, usually connected as well to leaderboards so you can compete with your friends or with the whole world, and to a lesser degree, chat. Chat is oftentimes not included because, well, who uses in-game chats if you have Discord? So that is more of a, go with the time situation rather than should it be done or not. The requirements that come out of this are basically you need a database to, well, save the values, for instance, of the leaderboards or who is friends with whom. To have this, you of course then need user accounts, because otherwise how are you going to identify the players to begin with? And finally, a whole lot of glue code to make sure that the things stick together. So this is, of course, something I'm not going to repeat in the next case studies, but glue code is going to be required in everything, all the time. Especially if something wasn't built with the intent of doing something else from the start. Now, for social play, the impact on the studio is actually relatively low. This is why it is used a lot, in particular in mobile games, because the added social component actually increases stickiness for the users to a large extent, and as we see, the actual return on investment can be high because the costs are comparatively low. They're not none, but they do cost something. More money. Operationally, you'll have a bit more things to keep on moving, meaning also maintain and pay for. And then, of course, because you have more infrastructure, more types of systems to account for, you will need more people, usually a live ops team, and you need more time to just put it together. Now, we are going to look at asynchronous, but specifically asynchronous in the sense that the turns themselves are one after the other. And also, more importantly, that you can play without the other person being live. And the two examples that we can look at for this is chess and tic-tac-toe. Those are probably the two most popular games that you can do online without much. I mean, chess.com is still exploding after the Netflix series, and tic-tac-toe is a game that we've all played when we were bored in school, so good, easy examples. In both of them, the important thing is these games are slow to the point that we don't have to worry about people expecting immediate results. Slow because we know the physical game that takes time, but also slow because, and that is particularly true for chess, less so for tic-tac-toe, is a time that people want to reflect on their next move. And so what this really means for us in terms of requirement for development is that we have to take care of the game state. We have to be able to save it, to load it, and to replicate it across devices. How we do this, we'll look in a second. Now also the other thing that is important here is authority itself is not necessarily critical. If you do play a chess game with your friends, you trust that they are not going to cheat. If you do play chess, well, for instance, over chess.com, and you want this at a competitive level and ranking, then authority becomes a critical part. And for this, because these games are so slow, we don't have that many requirements to begin with. We can have a database, of course. It can be as simple as an SQL database. That's fast enough for what we have to do. You need user accounts, duh. And we may want cloud scripts, but again, only in the case that we do need a level of authority over the movements or over the game states. In any other case, we don't care about it as much, if at all. And this is also why the real cost that we incur here is the development of these extra systems rather than anything else. The cost to buy these systems and operate them is not the same, because while these systems are basic and therefore cheap to operate, they can take a bit longer to integrate, especially if you need authority. But there's of course another type of asynchronous, and that's turn-based. Now, in turn-based, we need to separate two different types of turn-based games. We have sequential games, where basically, similar to the asynchronous games that we just saw, is one player does an action, and only after that there's a result, the other player will take an action. And simultaneously, where everybody takes the same action, but then the turn is executed using those actions at the same time. And the examples we can look at for this is, on one hand, XCOM. Granted, this is single player primarily, but it does a job here. Here, you always play you first, then the enemy, then you again, then the enemy. There is no interaction within the moment that you are acting itself. And then you have Stellaris as a counterexample, where everybody does their action, and then it gets computed, and that's the results. Now, they might be different in terms of how they're being presented, yet they can be lumped together as far as the requirements engineering is concerned. The features that we're looking at is player action synchronicity and a timer, maybe if we have to take control over the different stages of a turn. Now, what that translates to in terms of new requirements that have to be looked into for development is, one, if you need authority, you need a smart relay. If you don't need authority, you just need a relay to actually communicate that information between all the players. And this is probably the critical aspect to it compared to the asynchronous games that we just looked at before. In these games, you have more than two participants. Therefore, for a purely architectural reason and to save bandwidth both on your end as well as on the player's end, you want to have a relay in the middle that will just gather everything and then forward, instead of everybody trying to send everything to everybody else. Game servers, if the game is heavy enough that you can't operate it through the relay. Matchmaking, because if you want to fill up a whole session with people other than your friends, you will have to find them somehow. And of course, here again, user accounts. Now, this is really where the costs start to ramp up tremendously, because we have a whole lot more infrastructure. The infrastructure itself has to be coordinated because of the matchmaking and the sessions that may run on game hosting services. So we have 3 different levels that have to be tied together. And then, of course, that results in increased need for developers, more time and more operations because, well, shit costs money. But we go, okay, cool, real-time, turn-based. Turn-based is still relatively inexpensive. We can still handle it because there's nothing immediate. The real question comes here, real-time interactions, real-time multiplayer, and that is both what most people want to have, most people want to play, but it has the most restrictions ultimately because of everything we've seen before. And so to make this a bit more digestible, we're going to look at 3 different types of real-time multiplayer games. We're going to look at PvE, PvP, and then games that require a persistent world. Persistent world in this case meaning that the interactions that we're interested in are the ones modifying the world and the results thereof, how we interact with them. So, PvE, or in the case of Helldiver, PvP-VE. Why that distinction? Well, in this particular case, like in other PvE games, your actions also affect your other players and you can kill them. And why is that important? Well, it's important because you have levels, you have progression, you have ranks. And all of these things mean that if you have griefing, well, that's shit. And in this case, it's not PvP in the sense that you'll have Counter-Strike and go, okay, cool, like this is the whole point. Here it is a side effect that you have to deal with as a developer because it will affect the way you have to handle your community, the expectations that marketing has to set for prospective buyers, and the dynamics that will emerge within the community. What is more commonly looked at in terms of PvE is actually co-op. So, you know, my favorite game, Halo, well, favorite until the 3rd one anyway, is probably a good example for PvE where, yes, you can kill each other, but this is a game, when you play PvE, you're playing it with friends. Griefing is part of the thing that you might sign up with that dumbass that you invited to you place or that you have decided to add a couple of years ago and that you're still friends with. But it is not impacting your rank within the community as a whole. It's an experience that is segregated and that if you don't want that person to be annoying you anymore, you just don't invite them to play with you. So here, the features go much more complicated because again, we're looking at real time. So here, player interactions, not only player actions, but the interaction of the players has to be taken into account. The enemy player interactions as well, especially because there's a 3rd layer. Of course, then the inventory, primarily just because you need to know what everybody has equipped at a given moment, but also possibly because you need to be sharing items. And then finally, your character, because all of these games have, of course, customizations and other modifiers within your character settings. What that means here, and you will notice that it's very similar to the turn-based game in theory. The main difference is that we now have a host that can be either the player, if we're talking, you know, co-op games like Halo, because we as developers don't care to enforce an authority, and that makes it a whole lot cheaper for us, both in terms of operations as well as in terms of development cost. Then the servers to host the game sessions if you want something where you do need control, and then the relay for one of the two. Now the relay in this case is also important because especially for an example like Helldivers, not everybody will manage to connect to the server. There is on average an about 10% fail rate in what we call punch-through. So establishing a direct connection between your client, or the player's client to be specific, and your game servers. But you cannot and you don't want to have them be rejected because a player that doesn't play is a player that you lose forever. A relay in these cases will just be a bit of a degraded experience, but it will allow your players to still be part of it. Then, of course, matchmaking if you play with randos and you need user accounts for the same reason because you have to identify yourself over the network. And this is really where we're talking a whole lot more, especially in operational costs. The operational costs, if you're co-op hosted by players, then it doesn't increase that much because you don't have to operate it. If you have to have your game servers, then that will make a serious dent into your earnings. The time and the human resource required to develop that is reflective of the operational necessities. Now, we've talked a lot about Counter-Strike before. Here we go again. Counter-Strike, like most esports, and in particular shooters, the whole point is the player-to-player interaction. Everything else is disregarded. I mean, Counter-Strike doesn't have anything in the levels that affects the gameplay beyond what the players do. And so this is the same list, but with a key difference in the interpretation. And that is the player-enemy interaction is the same thing as the player interactions. Since your main target is the enemy here as well, but the enemy is dynamic, it's human, it's unpredictable, the requirement for you to validate it is incredibly high. Your inventory is important because, well, we have microtransactions this time around, most of it anyway, which means you also need to validate what they want to display, what they want to say they own, and of course you need to secure your transactions, both from a purely financial perspective as well as legally speaking, you expose yourself quite a lot. So that means we're now looking at hosted matches for the community by players. Those you don't usually care about, but it allows for modding more easily and other less critical interactions for the esports side of things. You need servers, of course, because you want control. The relay, as we mentioned, because of the failure rates. And then on top of that, you need matchmaking that is much more advanced, whether you're based on ELO or something else, in order to pair players with their equivalents in terms of skill or whatever your metric is for that. You need orchestration between the game sessions, both to fill them up so that you don't waste resources on empty matches, but also to start new matches and new sessions wherever you need them, whether it is in one region or in a different one based on where the players are located. And then again, of course, user counts. This time with more complexity because of all the previous points that we just mentioned. This is really where it maxes out. Like, this is the most expensive type of game to build to begin with, and even more so to transform into if you're starting from a single player point of view at the start. Best you can hope for is that you run your game authoritatively on the relay server, but then you have to pay for all the CPU time that it will take for the game to operate, and that is the most expensive part of any server. Bandwidth is comparatively cheap. Now, then we have games like Minecraft. And what do I need to say about Minecraft that you guys don't know already? It's basically really two things: world modification and world state. Now, that's easy-ish, because we could technically just save that somewhere if other people weren't there. But now we need to synchronize this live, then we need to save it somewhere when they're not there and put it back in. So here again, hosts, because in this case it's different. You want to be able to run it as a host, not for yourself, but because players want a community and want to run their own service for their own worlds that might want to be live 24/7. So in this case, you have to spend additional resources, not for yourself, but for your target audience. The relay, that is important for the same reasons as we mentioned before. The database and the user accounts is where it gets interesting. If you want players to be able to upload their worlds or have their worlds be available to other players that they're currently not connected with because they're offline, then you need a database from which the world state can be loaded at any time by anybody. And these worlds can get pretty massive and therefore take more and more space. User accounts here are only relevant to the extent that you need to be able to enable players to find each other, whether it's through friend lists, clan, or other methods. And that means persistence worlds or at least if you want to do something like a small version of Minecraft like it was originally intended, or Valheim, then it's going to be actually not necessarily that expensive to make or operate, but it's going to cost you more expertise and more time to develop, especially if you already have it. With all of that in mind, what is it that we can actually add in? Well, let me repeat what I said just before. Don't do it. You're basically ripping off a house from its foundations, rebuilding the whole foundation, and then trying to put it on. You can, but it's expensive. So don't do it unless you have a valid reason. And the valid reason is your product, your game, the actual game experience you're trying to sell to players. Not some stakeholder says, we need it because it's a cool feature that everybody else is using. If there is no value add to have that, don't do it. And be aware of the frustration and the rework that it requires. I know as an engineer myself that it's always fun to refactor things that you know you can do better now, but ultimately you also have to put something out the door to pay the bills. And also, and that is the most critical, that you have to definitely make any person that is not on the development team understand. If they want this, they have to choose one of the following things. Either they're basically doubling the budget because you're remaking the game, or they're postponing the release and just agreeing that, okay, it's going to take a whole lot longer, or they're shrinking the scope because you can't work on everything else that's in the pipeline. Of course, I know you all will have been asked for all three, but the opposite, of course, like increased scope, less budget, and sooner release, please, because now the people can play it even if we're not finished. But it's not that. And more importantly, it's not adding. That is really the key thing, that even if you can do it, even if adding is technically the right word, the mentality and the process is not that. It is hacking in new systems into something that it's not meant for initially, or it is really porting your existing systems and design to a whole new stack of technology so that it can operate the new desired way. With state transfer, you can build co-op and PvE games. It can be client authoritative and it can be hacked in. That is totally feasible. It's not going to be the best of experiences because, again, the design didn't intend for it initially, but it will be serviceable. And serviceable can be good enough if the whole point is to just have players being able to play together, and that's it. As soon as you go into PvP, yes, you'll need to use state transfer, but you have to have authority, servo authority usually, which means you have to port to a new type of infrastructure beyond just the technology. It means what you had planned for your post-release budget is going to be different. But with that in mind, you know what I know, and that's a wrap for today. Thank you very much for attending, and I'm open for your questions if you have any.